Puji dan syukur kita panjatkan kehadirat Tuhan Yang Maha Esa bahwa hari ini kita bisa berkumpul bersama dalam acara CS50X for Indonesian Teachers. Dan perkenalkan, nama saya Arleta Denisworo dan merupakan sebuah kehormatan bisa hadir di sini di antara Bapak Ibu semua. Dan sebelum memulai acara, izinkan saya untuk menyapa terlebih dahulu tamu-tamu yang telah hadir di antara kita sore hari ini. Ada Menteri Pendidikan yang terhormat, Menteri Pendidikan, Kebudayaan, Riset, dan Teknologi Bapak Nadiem Anwar Makarim, selamat sore. Gordon McKay, Professor of the Practice of Computer Science, Harvard University, Professor David Malin, a warm welcome to you and your team. Direktur Jenderal Guru dan Tenaga Kependidikan, Ibu Nunuk Suryani, selamat sore Ibu. Para pejabat di lingkungan Kementerian Pendidikan, Kebudayaan, Riset, dan Teknologi, perwakilan Jakarta Intercultural School, selamat sore Pak Phil Rickard and also Ibu Maya, thank you for being with us here today. Para guru hebat, peserta CS50X for Indonesian Teachers, gimana kabarnya? Para guru ini datang dari Sabang sampai dengan Merauke. Saya dengar ada yang dari Aceh, ada yang dari Papua. Semuanya masih semangat untuk mengikuti course ini sampai selesai, Bapak Ibu? Masih ya. Dan tentunya terima kasih juga kepada rekan-rekan media yang telah hadir pada acara sore hari ini. Dan mengawali acara sore hari ini, kita akan sama-sama menyanyikan lagu kebangsaan Indonesia Raya yang akan dipimpin oleh Ibu Rostiana Rawung dari SMKS Mutiara Baru. Hadirin, kami mohon untuk berdiri. Bapak Ibu yang kami hormati, izinkan saya untuk membawakan acara ini dalam bahasa Indonesia dan bahasa Inggris karena ada tamu-tamu kami yang tentunya dari luar negeri. Dan sekilas tentang acara ini Bapak Ibu, CS50X is a programming course offered by Harvard University for participants with or without prior programming experience. Now the course materials includes algorithmic thinking, problem solving, and use of programming language such as C, Python, SQL, JavaScript, CSS, and also HTML. This is in accordance with the spirit of the independent learning curriculum, in which teachers can create project-based learning materials. Now, this training program is a part of the educational transformation that starts with the teacher. Now, the teacher becomes an important figure for students' development in terms of their cognitive as well as their character maturity. By participating in this program, the teacher has great potential for forming students who have the profile of Pancasila learners through critical reasoning. For that, we would like to thank Harvard University, Jakarta Intercultural School, and MMS Group Indonesia, Yayasan Life After Mine, for assisting us with the beginning of this partnership in 2023. Thank you so much. Dan seperti yang tadi disampaikan bahwa peran guru ini luar biasa pentingnya. Jumlah peserta guru tahun lalu ada sekitar 150. Tahun ini bertambah menjadi 270 guru yang ikut berpartisipasi. Dan ini merupakan inisiatif dari Direktorat Jenderal Guru dan Tenaga Kependidikan. Oleh karena itu, selanjutnya kami ingin mengundang untuk naik ke atas panggung Direktur Jenderal Guru dan Tenaga Kependidikan Ibu Nunuk Suryani untuk menyampaikan laporannya. Kepada Ibu Nunuk kami persilakan.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Shalom. Om Swastiastu, Namo Buddhaya, salam kebajikan. Untuk honorable guest, Indonesian Minister of Education, Culture, Research and Technology, Pak Menteri Nadiem Makarim. Berjumpa Professor of the Practice of Computer Science, Harvard University, Professor David Malang, Official and Eselon of the Indonesian Ministry of Education, Culture, Research and Technology, Jakarta Intercultural School representatives, and all participants of CS50X program. Pak Menteri, ladies and gentlemen, I am very grateful because today we have the opportunity to take part in the opening of the digital skill for teacher seminar in the CS50X Indonesia Harvard University Micro-Credential Program Series. The Directorate General of Teachers and Education Personnel of the Indonesian Ministry of Education, Culture, Research and Technology has collaborated with the Education Flight Management Institute (LPDP) to recognize the CS50X Indonesia Micro-Credential Program at Harvard University. We should be proud because after successfully organizing the pilot program last year with 150 participants, this year we can hold it again with a total of 272 teacher participants of middle school, higher school, and vocational school levels. Ladies and gentlemen, in the end, the teachers participating in this program will later return in their respective regions to teach in their respective schools, and the students are expected to be able to think algorithmically and solve problems efficiently. For the reason, I cannot wait to hear the story of the impact that the teacher felt when participating in this program, and what is most important is the subsequent impact of the teacher, students. Thank you for listening. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
This is CS50X
Indonesia University.
Terima kasih, Bu Nunuk. Wow, I see the teachers are very enthusiastic about this course. Well, talking about AI is a much talked about topic lately, and I know that everybody here in this room has so But hopefully after this event, all of your unanswered questions will be answered by the expert himself. He is the most well-known expert in computer science who teaches CS50 at Harvard University. So without further ado, ladies and gentlemen, please join me in welcoming Professor David Mayer. Take it away.
We are thrilled to have students, parents, teachers, and special guests join us today as we delve into the fascinating world of AI and its impact on our lives. Thank you, though, first to our friends at GIST. Thank you, of course, to the Ministry of Education, Mr. Nadeem in particular, and to so many of those of you who made this possible. Perhaps most importantly, CS50, this class I teach, ends every semester with a final project, a capstone, in which students are challenged to write their very own piece of software. It is not a homework assignment that we ourselves assign. We invite them, invite you to create whatever it is you would like. And I'm very happy to say that as of just a few hours ago, our teachers' final projects were due and submitted, in which case we can now proudly say that all of you here today of CS50 that you didn't yet have. In fact, everything you are about to hear today didn't exist within CS50 literally 1 year ago when your predecessors, your 150 teachers, took CS50 and are now out there in the real world teaching computer science in their own classrooms. All of this work began really in June of 2023, which was after our last visit. So this is hot off the press, so to speak. And what I thought I'd share with you, particularly those of you who are not teachers who've just taken CS50, is a glimpse at how we have been using artificial intelligence, or AI, within the course itself, how we think it can be generalized to education more broadly, but also to give you a sense, this is where it's going to become a bit like school, of how AI itself works. So that when you exit today, even if you don't even consider yourself a technical person and not very well versed in AI, you will in fact have a better sense of how this technology works, at least as of today. This is something that's going to continue to evolve, and through CS50, indeed, we hope all of you teachers have enough of a foundation in first principles, so to speak, and in the basics, so that you'll be very easily able to adapt in the coming months, the coming years, to all this and other technologies as well. So this is what artificial intelligence looked like in CS50 just 12 months ago. We had a rubber duck, physical more than virtual, and we implemented a software tool by which students and now teachers can interact with this duck and ask questions of it if they're having trouble with the course material. If you were to ask a question, like, I'm hoping you can help me solve a problem with the duck, that is as specific as some students' questions get. The duck, aka duck debugger, or DDB, would respond with 1, 2, or 3 But of course, as you teachers now know, you had access to this duck through the entirety of your experience, but last summer, essentially, some of our online students were very surprised to duck started answering questions in English. And that's all thanks to some of CS50's team members here and back home in the US and around the world. And so what you are about to see is indeed a work in progress, but very resonant with the very technologies you probably now used or certainly heard about, be it ChatGPT, DALL-E, or others. So in fact, let's begin there. It was around this time last year, before this duck was brought to life, that the latest and greatest implementation of artificial intelligence was with images, really. And AI has been with us, certainly in academia, for many, many years, but DALL-E 2 and software like Midjourney allowed you to type in words in English or any human language and get an image generated for you that hopefully looked like what it was you typed in that language. Of course, this led to a lot of discussion about what was now possible, both good and bad. For instance, within the New York Times, a big newspaper in the US, were images like this put forward as evidence of both how good this technology was getting, but also how imperfect it still is. For instance, if you zoom in as they did on his hands here, this is generally not a direction that human fingers should go in. And so to this day, there are certain tells, slight hints that maybe this was not in fact legitimate. It's not a photograph, indeed AI. Now I do think, and this is a topic for a broader discussion, this is going to get harder and harder. Our implementation of fingers is going to get better and better, so there is a very real threat and concern around disinformation. But for today, we'll focus largely on the technology and how you might discern one of these images from real or not real. And so in fact, allow me to invite one of my colleagues to come up on stage here, Carter. Some of you might know from the course itself. Welcome aboard. With you to go to this URL on it, cs50.ly/poll, P-O-L-L, or you can scan the QR code. And if I'm in the way of your code, you can go to any one of these identical codes. That should open your browser to a polling software that we use in class itself back home. Give you a few more seconds. If it doesn't work for everyone, that's okay. Follow along with the person next to you. But maybe by some nods of the head. Do most people have it working on their screen? Hopefully, okay. So seeing that, let's go ahead here and pose a challenge problem to you. Homework exercise if you will. You could advance one slide. Here are two images. Here are two images, left and right. And Carter, why don't we go ahead and now ask folks a question about these two images, left and right. So left and right. Which was generated by AI? The one on the left or the one on the right? On your phone, you should be able to just tap your response. And as the numbers are coming in, it looks like the majority of you think the image on the right was AI generated. 8% unsure, 27-ish% left, now 26. So some of you are perhaps changing your vote. But Carter, what in fact is the right answer here? It was in fact the image. Yes, we won this one, but let's go ahead and try another now. So Carter, we can advance to the next image. Same URL, so you don't need to rescan it. Here are two faces. Which of these was generated by AI? Left or right? Left or right? Which was generated by AI? Left or right? A lot of confidence in that last vote. But let's go ahead and see how the numbers are now looking. And here we have 71% more saying left, 54% right, and 7% unsure. Unfortunately, this was a bit of a trick question, Carter. These are both.
Oh my God, tadi aku udah.
Of course, nowadays with ChatGPT and other forms of AI, it's not just images. Now we're seeing English, Indonesian, and other human texts being generated. For instance, here is an essay of sorts. Essay 1, I like to bring a yummy sandwich in a cold juice box for lunch, and sometimes even pack a tasty piece of fruit or a bag of crunchy chips. As we eat, we chat, we laugh, and catch up on each other's day. Essay 2, my mother packs me a sandwich, a drink, fruits, and a treat. When I get in the lunchroom, I find an empty table and sit there and eat my lunch. My friends come and sit down with me. Now I claim that both of these would seem to have been written by a 5th grader, a younger student in primary school. But Carter, we can ask our final question here. Which of those texts was generated by AI? Essay 1, the one on the top, or Essay 2, as Carter has shown here? Which of these was generated by AI?
The answer is essay 1.
Folks, another couple of seconds.
Udah jawab.
Iya, terlalu tipis.
Closer. Closest of them yet. 56 on essay 1, 40% on essay 2. And Carter, the correct answer in this case was in fact.
Very perfect one.
And it's funny to see like games like this. I dare say more and more are the challenge problems going to become like the second one, where it could be the one on the left, it could be the one on the right, but actually both of them, all of them, are generated by artificial intelligence. And indeed, text is where the world is now steering. And in fact, by a show of hands, how many of you have used or certainly heard about ChatGPT, which took the world by storm just a few months ago? This was a conversation. This was a word we didn't even use last year because it wasn't out there in people's vocabulary. And so this has caused quite a bit of consternation in educational circles, for universities, primary schools, secondary schools, and the like. Because what does it mean for how students learn, how we teachers teach? And what we took the approach of was this within CS50. As some of you know who have now taken it yourself, we by policy have decreed in recent months that for now, using ChatGPT and tools like it, GitHub Copilot, maybe Chat and others, that suggests or completes questions, answers to questions or lines of code, we simply deem it not reasonable to use it. It is considered within our course right now academic dishonesty to ask questions of ChatGPT, if only because these tools are just too helpful right now. They're too eager to please. They're too eager to just do the homework for the student. Surely, though, there's a better inflection point where you can get help with questions and better understand the material without it being completely spoiled for you. And so the middle ground we established, which as so many of you teachers now know, is that it is reasonable within CS50 to use our own AI-based software, including the virtual duck that you saw before, the English-speaking version thereof, at two of the domain names, CS50.ai and CS50.dev, that we ourselves use. And so it's via those websites, those web applications, that we ourselves have built on top of OpenAI and Microsoft Azure and experimented with other platforms that brings that duck to life, blinking as it here is on the screen. So for those of you with these computer science backgrounds, here's an architectural diagram of what's going on underneath the hood. And even though you see it as a friendly virtual duck, what's really happening is this kind of complexity underneath the hood. If the student is there pictured at left raising their hand virtually, the student is using a website like CS50.ai, or the programming environment you all now know. We are then talking to Microsoft services, Microsoft Azure, OpenAI, and so forth. But we too locally are sort of teaching the duck more about CS50 specifically, especially when we might have just had a class yesterday and we want students to be able to ask questions about the material that OpenAI has never seen. We also have this top portion where we have our own vector database where we use other techniques to make sure that the duck is as up to date as is possible. But for a more colloquial conversation about this, let's consider some of the new terms of art that people weren't really talking about a year ago, like prompt engineering. Like now it's a thing to be a prompt engineer. You might see it in someone's LinkedIn profile, for instance, that they're really good at prompt engineering. Well, this is kind of an overstatement. It's not really engineering. It's about getting an AI to do what you want by coming up with good English explanation, English instructions or Indonesian instructions that sort of coerce the AI, the duck in our case, to answer a question as you might intend. And so we, for instance, do this within CS50 by having our own system prompt for the duck. Another term of art that just means that we've written some lines, not of code, but of English, that essentially teach the duck to be a duck. Because if we just use OpenAI off the shelf, it's really just ChatGPT. It just wants to answer any and all questions, no constraints in place. But we want to put in some pedagogical guardrails so that the duck tries to help you, but not by giving you the entire assignment, but maybe just a little piece to help unblock or unstick you. So for instance, the kind of language that we teach or train the duck with looks a little something like this. Quote unquote, you are a friendly and supportive teaching assistant for CS50. It's the very first thing we tell the AI. The second thing we tell it is that you are also a rubber duck. And that alone is enough to coerce that kind of behavior. But we do go on. Answer stupid questions only about CS50 in the field of computer science. Do not answer questions about unrelated topics. Do not provide full answers to problem sets in this violent academic honesty. Answer this question, colon. And what we essentially do after that is copy paste the question that you teachers, your students, ask of us so that the duck has a personality like this. And these pedagogical guardrails, so to speak, are just meant to put downward pressure on the duck's default behavior, which would be, here is your entire homework assignment. And so it really is, this is prompt engineering. It's not so much writing code, even though we have written some code to make that whole diagram work, but it's about coercing the AI to behave like you might intend, whether it's for a computer science class, a physics class, a humanities class, a customer service line for a company online. This is how these AIs are getting these different personalities. And what you, the teachers, or you, the students, type in, one last term of art, is user prompt. That's the question you and I are asking in our own human language. So how does CS50 now use these AI? So many of you teachers know, but just even those less familiar in the audience, here, for instance, is the URL that one of those tools image, CS50.dev, which is a cloud-based version of a very popular industry-standard programming environment called Visual Studio Code, freely available from Microsoft to download or use, in this case in the cloud, on top of another service called GitHub. The very first thing we did, June of 2023, so not long after leaving Jakarta last time, was start to experiment with this. Could we write an AI that explains to students how their code works, or how code their teacher has given them works, so that they can better understand it? So here's a screenshot of this programming environment. Here is some code in a language called C, as so many of you now know. But this is a program that might not be familiar to a new student, and so if a student now, as of 2024, highlights one or more of those lines of code, right-clicks and selects Explain Highlighted Code, what the duck will do in this case is, in English, or technically in other languages too now, explain step-by-step how that code's working without any human, any teacher having typed all of this out for the student. Within seconds, your students get a response like this. So we next considered, what more can we do with this to try to tackle a well-defined problem? So could we have the duck advise students on how to improve their code style, the aesthetics, the formatting of it, so it's just more readable to themselves, their teachers, their colleagues? And so here's that same programming environment with some ugly code. Everything is left aligned. It hasn't been indented with tab or spaces. But in this case, students can now click a button that shows them on the right-hand side what their code should ideally look like. And if they don't quite understand or can't quite visualize what has changed, they can click a button, explain changes. And here too now on the left, they get an English description of how to make their code better and in fact why. And so we took on these very bite-sized problems, so to speak, really just to eliminate the need for a teacher to have to answer questions like this, which might lead to interesting conversations, but so many, whereas a teacher, a school might operate 9 a.m. to 5 p.m. or thereabouts, so many students, certainly at the university level, are doing their homework 5 p.m. to 9 a.m., so there just isn't that same support structure in place. And so now this is a duck that is there and willing to answer questions in the end of the time. So there's also this other tool we've used for those less familiar. It's a web-based tool by which students for years have been able to ask questions, but now, instead of us humans answering all of the questions at whatever hours we are awake, John Harvard here, as an imaginary student, might have asked a question like this. And for those of you who don't know programming, let me just stipulate, this is a pretty nuanced question, because it ends with, is there a more efficient way to write this code? That's not just a factual question, it's more subjective, more qualitative. But the duck, this is an actual screenshot, responds with, what I'll claim for today's purposes is a very good nuanced answer as well. But notice it doesn't spit out lots of lines of code. It limits itself to just 3 or 4, as per the guidance in that system prompt from earlier. But moreover, we do nonetheless include this disclaimer at the bottom, insofar as AI is still very nascent, it's very experimental, and it will make mistakes sometimes, though thankfully not frequently. But we remind students at least to think critically, as they should be doing anyway educationally. But we also have this mechanism in top right, whereby for now, we also have humans reading every one of the duck's responses in this environment and clicking on it to endorse that, yes, this is definitely indeed a correct answer for students. And what students can also do now, rather than just using this tool, it's now its own web application, as you now know. CS50.ai provides students now with virtual office hours, opportunities for one-on-one virtual support anytime, any day of the year. And so if you go go, for instance, to this URL, anyone even in this room after today with a free GitHub.com account can log in and try this out. You'll see an interface quite like ChatGPT. Similar disclaimer up top, reminding students to think critically about their answers. A student, though, can now ask even more technical questions, like, my code is not working as expected. Any ideas? Giving us this actual Python code in this case, and this is an actual screenshot that Duck replies with this, which for today's purposes, I'll stipulate, is a very good, nuanced answer as well there at the bottom, even providing code that shows how to correct this very specific problem. So ultimately, sort of holy grail, I think, pedagogically, of all of these tools, even though right now they're very CS and CS50 specific, is that you can really, with software, approximate the one-to-one teacher-to-student ratio, which no matter how resourced the school is, it is a rare thing to see fewer than 5, 10, 20, 30, or even more students in a classroom. One-to-one is very, very rare and unprecedented in those places. But with software, we can begin to have as many, and maybe ideally even more teachers physically there, but to focus their most precious resource, their time, their attention, really on the students who might need it the most, want it the most, benefit from it the most, while still uplifting so many other students who might be quite comfortable interacting with the AI in this way. And just to give you a sense then of scale here too, as we begin to iteratively try to improve this, CS50's own software is up to 90,000 users so far, about 300 of whom are here now today. You all have been, I guess, asking 19,000 questions per day, though. So far, 3.4 million prompts or questions to date.
Satu orang, 100.
Last year in Jakarta. And one of my favorite quotes from students, we share more of these online in a paper that we'll soon share with the CS community, is a student this summer wrote this. It felt like having a personal tutor. I love how AI bots will answer questions without ego and without judgment. Generally entertaining even the stupidest of questions without treating them like they're stupid. It has, as one could expect, an inhuman level of patience. And again, even though it's very CS specific, any of the Q&A, questions and answers, the CS50.ai, really by just changing the system prompt, even today, could we coerce the duck not to be a CS50 duck, but to be a physics duck, an arts class duck, a humanities duck, or really any other field. And there's more nuance than that, and we're trying to make it better and better, but that's already where we are, where even a student who's taken CS50, even a teacher who's taken CS50, can write just a few lines of code and embrace and leverage this kind of technology for their own applications as well. So how does any of this work underneath the hood? Here's where it's sort of class time for our final moments here together. And this is all a big example of what the world is calling generative artificial intelligence. AI has itself been around for years, for decades. There were courses in college that I could have taken, but didn't at the time. And now I'm very excited to revisit those now. With generative artificial intelligence is all about using AI to generate images, video, text, and so much more. So when it comes to generative artificial intelligence, underlying that is primitives, principles that have been with us for years as humans, as researchers, computer scientists have been figuring out how to model intelligence as we currently understand it. So let's take some simple examples. We've all sort of taken for granted that Gmail and Outlook have spam folders, but how does the email get there? There isn't some employee at Google or Microsoft, of course, like putting all of your spam into that special folder, and there isn't even a piece of software that knows what the spam is supposed to look like, because what if someone just created a new spam message? So already we've seen in the real world algorithms, software, that sort of figures out with high probability what is spam and what is not. Handwriting recognition. If you've ever used a tablet device or some other, Google, Microsoft, Apple, they don't know your handwriting from mine or anyone else, but generally speaking, the strokes we use when drawing on a screen are pretty similar across humans, and so their software figures out with high probability if that is indeed an H, an E, an L, L, O, and so forth. Watch history. Those of you who might watch all too much TV or movies might have software nowadays recommending to you what else you might like. And that too is not because someone knows exactly your taste, but can infer, thanks to some statistics, some probability, some math, what it is you might like based on your past behavior. And then of course there's Siri, Alexa, Google Assistant, and other voice tools that also don't answer this. If the human asks me this, then answer me this. There's no very long conditional or if-else condition that's doing that. They're trying to figure out dynamically what it is you just asked me and how should I answer. But let's start more simply. Let's rewind a few decades of time too. This was one of the earliest video games called Breakout. Very similar to Pong, but it's actually one player, and it allows you to move this red paddle on the bottom, left to right, and there's this red ball, which back in the day was literally just a single dot or pixel on the screen. This is the state of the art, and the ball bounces back and forth, and you try to break all of the colorful bricks that are on the top of the screen. Now this is a nice example because even if you've never played this game before, you probably have an instinct for which way you should move the paddle in order to get the ball on the way back down. Should you go left or right with the paddle? Probably to the left, because I'm guessing if the ball came from the paddle that way, it's going to go down this way as well, so maybe you want to move the paddle to the left. Now that's great, because if you agree with me that that's kind of the heuristic, I bet we could train a child to understand and play this game, but I also bet we could program a computer. And how do we do that? Well, some of the earliest forms of AI just use something called decision trees that you see in other fields too, economics and strategy more generally. But a decision tree is kind of like a family tree where you might have the mother, the father, and the kids down here. So you sort of draw it hierarchically. And we know this in CS50 as a tree data structure. So how might you decide whether to go left or right? Well, you ask a question, is the ball to the left of the paddle? If so, then move the paddle to the left if indeed yes. But there's another scenario. If the ball is not to the left of the paddle and your answer is no, you might think initially I should move to the right, but it's not quite as simple as that, because there's another scenario. What if the ball is to the right, or maybe it's right where it should be? So you have to ask one more question. Is the ball to the right of the paddle? If yes, well, move the paddle to the right. But the third case that a good programmer would already see coming would be, well, no, then go ahead and don't move the paddle. There's three possible scenarios. And this is a decision tree because no matter where you are in the game, you can just ask yourself step by step these questions and win the game consistently, or at least not lose the game, because you'll move the paddle in the right way. So what can we take away from this? Well, here is how we might translate this as code. This is just pseudocode here, but while the game is ongoing, if the ball is to the left of the paddle, move the paddle to the left. Else if the ball is to the right of the paddle, move the paddle to the right. Else, don't do it. So this is pseudocode, but it looks like Python, which so many of you just spent the past few months programming in. But let's try a more sophisticated game. If you two grew up playing tic-tac-toe, for those unfamiliar, this is a game you can play on paper pencil, and it's got a grid of 9 squares, and there's an X player and an O player. They just alternate turns, and the goal is to get 3 O's in a row or 3 X's in a row, either vertically, horizontally, or diagonally. And that's it for the game. So at this point in the story, O is about to win, because if O goes right there, it's going to get indeed 3 in the row. So let's consider how we can decide, though, more programmatically, more intelligently, how to win this game, especially if it's not as obvious as that, but maybe you're just starting. How do you optimize for winning this game? Well, you might ask yourself this question. In this case, can I get 3 in a row on this turn? Well, if so, you should obviously do that move, and for instance, play in the square to get 3 in a row. But if you can't win on this move, you might think, well, I'll just pick something random. But you should be smarter than that, more intelligent. You should consider, well, can my opponent get 3 in a row on their next turn? Because if so, you should block that person's move somehow and go into the square to block the opponent's 3 in a row. But here's where AI starts to come in. Well, what if the answer is no? What do you do if there's no obvious win or defensive move at this point? You could go random, but maybe we should try to think even more steps ahead. And you could, in fact, do this. In fact, let's kind of zoom out a bit. If the board now looks like this, with just one square played with an X, and it's O's turn, I mean, O has 8 possibilities. I mean, how do you begin to think about this? Well, it turns out that with AI, it's really good at games because you can represent even something like tic-tac-toe, at the risk of taking all the fun out of it, mathematically. You can represent it with numbers, with functions, but kind of use a universal language that we humans and computers can also speak and understand. So there's this algorithm. It's one of the first algorithms a student learns in an artificial intelligence class called minimax, for minimization and maximization, to make something really small or really big. And so for instance, let me stipulate this. For tic-tac-toe, if you've got 3 boards here, we just need to come up with a universal system for scoring this game. And let me propose arbitrarily that if O has 3 in a row, let's just call it a -1 score. If X has 3 in a row, let's call it a +1 score. And if no one has 3 in a row, we'll just call it 0. It doesn't matter what numbers we use. We can use A, B, and C, X, Y, and Z. We just need some way of representing this. The numbers are a nice go-to because computers and humans understand them so well. And here's where minimax comes in. The X player, by definition, wants to maximize its score, and the O player wants to minimize. So what does this mean? Well, here's the sample board. It looks like X has 1, so just as a check here, this board would have a value of 1. Well, now let's rewind to where there's 2 moves left, and let's suppose that it's O's turn. How does O decide what to do? Well, O's goal in life is to minimize its score. So that is to ask, what is the score of this board? Well, it's not obvious yet, but here's where decision trees can come in. What is the value of this board? Well, it depends. If O goes top left, or if O goes bottom middle. If O goes top left, as in yellow there, that invites the question, okay, at that point in the story, what is the value of the board? Is it -1, is it 1, or 0? Because that's going to dictate what O does ultimately. Well, if O goes top left, the only move next for X is to go bottom middle, at which point X wins. And so the value of that board, if this is how the game is played, is a positive 1. There's only one way to get to that board, logically, in this decision tree, so really the board above it also effectively has a value of 1 by transitivity, mathematically, if you will. But we don't know if O wants to go that way yet. On the right-hand side, suppose that O goes bottom middle, and X goes top left. No one has 1 at that point, because no one has 3 in a row, so the value of the bottom right board is going to be 0, because it's a tie. That means the board above it, which is the only way to get to it logically, is also 0. And again, we come back to minimax. If O's goal in life is to minimize its score, should it go to the left, or should it go to the right? What should O do? It wants to minimize its score. Probably go after the 0. It's not a win. O cannot win this game, but it can at least prevent X from winning. And that arguably is still better than losing outright. So that is to say logically, if we think about AI as a sequence of decisions, well, what the player should do, AI or otherwise, is go with the top, the bottom middle, so that the value of the board is indeed 0, so at least no one wins. And that's strictly better than X winning instead. But here's where life gets complicated. That isn't really AI. That's just a lot of if, else if, else if, else if statements in Python or some other language. But what if we back up? If there's 3 moves instead of 2, the decision tree just got essentially twice as big. And if you zoom out further to go to 4 moves left, 5 moves left, all 9 moves, the decision tree just gets really, really big. And you could write it down. You need a really big piece of paper, or frankly a computer. But tic-tac-toe is not the worst of our problems. If we consider how many possible games there are in tic-tac-toe, it's a lot, but it's not a scary number of games. There are 255,000 ways to play tic-tac-toe. So even if you think tic-tac-toe is boring, even if your kids play tic-tac-toe and they're sort of bored of it, they have probably not played every possible permutation of tic-tac-toe, so they should hang in there. But 255 games is something any computer can do. There's more challenging games like chess, for instance. If you look at only the first 4 moves of a player going once and the other player, then again, then again, then again, and that's it. A few minutes of time, perhaps. There are actually 288 million ways to play just the first 4 pairs of moves in chess. And if you know the game called Go, there are 266 quintillion ways to play the first 4 moves of that game. And you could still use minimax on all of these games. You could get out a really, really big sheet of paper, but none of us are going to be alive long enough to be able to write down all of those possible moves, which is to say, this just doesn't work in the real world. At least not in 2024. We don't have enough time in the day. We don't have enough computers, enough memory to solve problems once they get that big. We need to be more intelligent. We need to learn how to win these games or play these games rather than just use decision trees step by step. And so that's when we get to machine learning, where the code that you and your future students will write will not be if, else if, else if, else if, else if. It's going to be the right code that doesn't even know what problem is going to be solved, but it needs to be able to learn how to solve it based on training data. Examples of playing tic-tac-toe or chess or Go, where the computer just kind of figures out how it should try to maximize those games. And you can see this in different ways. For instance, reinforcement learning is one way to teach a computer to do something without writing code step by step. You sort of positively reward the computer, you give it a treat if it does something well, and you punish it in sort of a metaphorical slap on the hand if it does something poorly. And the idea is that through positive and negative reinforcement, the computer, the robot if you will, can learn So for instance, a fun video that I shot I'd share a few seconds of is this. Here is a researcher in a computer lab using a computer, but that computer is driving the robot that you see here, and this man is trying to teach this robot how to flip a pancake. But he's not writing code to do it. He's trying to show the robot one or more times how to do it properly, again and again, and presumably now the robot has some amount of memory, but it's going to try to replicate that behavior. It's not perfect. He didn't do the exact same motions all 3 times, so the computer, the robot, needs to infer. And so after 3 times, 5 times, this is not how you flip the pancake properly, but the researcher or an assistant is probably off camera either giving a +1 score to the robot or a -1 score, because the robot's then going to want to do more of the +1 and less of the -1. So a system of rewards and punishments virtually, if you will. Now it's getting better at 15 after 20 trials. It's still not perfect, but you'll see here that it's hopefully learning. And here is just another angle that shows you how these physical motions really just reduce to math, some geometry on the screen, up, down, left, and right. And now the robot is indeed flipping that pancake better and better. And if we keep going with more and more trials, it should be able to repeat that again and again. Here we are from the first angle after 50 attempts. Now it should pretty much get this right again and again. And funny enough, this probably is not unlike how we humans, how a child, how a chef learns to do something. You keep practicing and practicing and practicing. And if you have someone there, especially telling you like good job or bad job, hopefully you do more and more of a good job effectively learning in this way. So now when we consider not pancake flipping, not game playing, but some of today's problems that intersect with tools like ChatGPT and the like, let me propose that we consider what's called nowadays deep learning, where you really just feed the computer lots and lots of data, so much data that you don't have time, you don't have the resources to pay a human to teach the robot. You just want to feed it lots and lots of data and let the computer find patterns, figure out how to solve certain problems. And so, the term of art that you might see tossed around in this space are what are called neural networks. And long story short, for today's purposes, neural networks draw inspiration from how we humans think the human brain currently works, where you have lots of things called neurons that might look a little something like this, blown up to scale, and they have some kind of electrical interconnections that can transmit signals from left to right, top to bottom, and so forth. And if you have enough of these neurons, it turns out you can effectively use them to implement math and represent information. Like here's how you might connect 2 neurons, but honestly this isn't a biology class, this is a computer science class, so let's abstract this away as we often do. Here are 2 neurons, but just with circles, but some edge between them, so there's some form of communication, not unlike today's networks. And if you now have 2 of these neurons on the left and 1 on the right, you can imagine using this to implement a problem to be solved, where you have 2 inputs on the left, and you want to figure out what the output is on the right. Let's try something simple. Here is a very contrived world in which you have an XY grid, vertical and horizontal here, and suppose this world is filled with blue and red dots. And you don't know what makes a dot red or blue, but if you show me enough red and blue dots, I bet I can start to figure out or infer, either as a human or as an AI, whether a dot, given its X and Y location, is going to be red or blue. Well, how might I do this? Well, I can start simply here on my XY grid, and I can just propose that if I wanted to give as input to this problem an X coordinate, like a number, a Y coordinate, a number, I want to get back an answer red or blue on the right. Well, the simplest way to do this, honestly, is just to kind of ballpark it. Okay, it looks like I can draw a white line there, and anything to the left is going to be blue, apparently, and anything to the right is going to be red. Now, that might not necessarily hold true with more data. So the more training data you have, you're like, oh, darn it, I need to adjust my line. So for those of you familiar with math or statistics, trying to find a best fit line for this data. All right, so let's try a diagonal line instead. Let's throw some more data on it. This line looks pretty good. And unless I want to start getting in like some parabolas in there, and x squared and y squared and sort of fancier math, this is a pretty good line because like 80%, 90% of the time, the computer, or me, the human, is going to be able to predict red or blue correctly. And so what's really happening here is we really need to figure out what the mathematical formula is for that line. What is the x, the y, the a, the b, the c that kind of makes all of this work? And again, this is as mathematical as we get today. You're essentially trying to figure out dynamically, through trial and error, what is this formula? X and y are the actual coordinates of the dots, but what is A, what is B, and what is C that makes this formula work? So that if the answer is greater than 0, let's call it red. If the answer is equal to or less than 0, let's call it blue. Or you can flip it, it doesn't matter. But what you're trying to do through more and more data is infer what that math function is. And in practice, it's not as simple as 2 dots on the left and 1 dot on the right. You have multiple layers. And so the mathematical formula that AI software is coming up with is much more complicated, so much so that if you ask even the smartest engineer at Microsoft, Google, or in the real world, they can't even tell you what most of those dots represent, because it's just something the computer came up with as sort of a best fit attempt for that data. We might understand the inputs, we might hope for the outputs, but even we humans don't necessarily understand how all of this is working. And yet it's so darn powerful. You can feed to a computer nowadays lots and lots of examples of like human written numbers, 0 through 9, and the computer can effectively, given enough data, figure out how to get from a handwritten 8 to a virtual version of 8. And how might it do that? Well, here's a really, really big neural network, and every one of these dots on the left, there's 784 of them, represents a specific square in the square at top where the human has written some letter. So you can represent each of these dots as maybe it's black if it's blank, white if there's actual text there, and given those 784 dots that compose any number, you can ideally figure out that, you know what, that looks with high probability like a 2. And that brings us lastly then to these large language models and CS50's Duck and tools like ChatGPT. They too are leveraging exactly those principles of using large amounts of data to learn deeply on. They are using neural networks to kind of figure out what the patterns are in all of the English words and sentences in the world, all of the Indonesian words and sentences and paragraphs in the world, figure out what those relationships are so that when you or I type a question in, they can sort of traverse that whole neural network and figure out with high probability, when I see these words as input, I should probably echo these words as output. And it's not always going to be right, but indeed it does its best effort now, and it's only going to get better as the duck here has come alive. And in fact, just to get folks talking over the weekend and the coming days, as you probably already know, AI makes mistakes and hallucinations is the term of art that the world has co-opted to. It's really a plain way of saying that the software is wrong. Like it gave you the wrong answer, but very confidently so. And I'm reminded of this comic strip that we ended CS50's own lecture this year when he was added to the course on, which is by an American author named Shel Silverstein, which years ago sort of hinted at exactly the situation we are in. So I thought I'd end with this comic here. The homework machine. The homework machine, oh the homework machine, most perfect contraption that's ever been seen. Just put in your homework, then drop in a dime, snap on the switch, and in 10 seconds time, your homework comes out. Quick and clean as can be. Here it is, 9 plus 4, and the answer is 3. 3? Oh me, I guess it's not as perfect as I thought it would be. And so that's then where we are. If you want to learn all this and more, please do. If you're not a teacher in the group who's already done this, join us online anytime at cs50.edx.org. And so very thankful and grateful to all of our hosts and supporters here in the room. And we're so excited to meet so many of you here.
Memberikan kesempatan kepada para guru, mungkin ada yang ingin bertanya. Step down from the stage because we're going to set up the stage for our fireside chat. Oh my, there's a lot of questions. Oke, kita mulai dari paling depan. Silahkan Ibu dengan Ibu siapa dan dari mana?
Okay, thank you for welcoming me. My name is Angelica. I'm from Sidoarjo. And my question is, how AI can be a solution for developing conventional thinking? And actually, I still have doubt about that because I have story about my students. My students is still have opportunities to use it for cheating. I'm not talking about our duck, our lucky duck, because it already setting with incredibly awesome. So I talking about another tools AI that can provide our students to have more conventional thinking. Thank you.
Okay, thank you for the question.
I think we'll discuss some of this with Minister David a little bit.
All right.
I can say I think a lot of this is not technological. celebration of ethics and academic honesty in classes, and I do think that's easier said than done. But these technologies are not going anywhere, and with phones in every student's pocket that are not on the campus network, we will not be able to prevent these schools. And I think the best path forward is really, as best we can from the earliest age possible, trying to encourage students to appreciate when and how they should use tools like this. That I think is the opportunity.
All right. So I know that you have a lot of questions, but I know that tomorrow you start with the course, and now we'll have the fireside chat. So, Professor, you may take your seats right on the left, yes, on the left-hand side of the stage, and we will have our fireside chat. And then I would like to invite to come up on stage our fellow teacher of CS50X program. Please welcome Ms. Nikma Fadila. To invite Mas Menteri to please join them on stage for the fireside chat. All right, Ms. Ima, the floor is yours.
Assalamualaikum warahmatullahi wabarakatuh. Afternoon, ladies and gentlemen. Welcome to the spectacular evening today. This event is a collaboration between the Indonesian Ministry of Education, CS50 Harvard University, and Jakarta International School. My name is Nikma Fadila, and I will be the moderator in this event. I am grateful can sit here with the two great people, Professor David Melon, current Professor of Computer Science at Harvard University, and Mas Menteri Bapak Nadiem Anwar Makarim, Minister of Education, Culture, Research, and Technology of Indonesia. So, Professor Melon, this is the second visit to Indonesia. How was your flight? How was Jakarta?
This will be the easiest question, I think. Thank you. I was personal as could be, and it really is amazing that it's been a year since we were here. Time has flown, and clearly, so much has changed. And we're so very happy to see not only past teachers, but presidents and all of our
Just want to check, can everyone hear us right now?
Yeah. Very clear.
How was my day? My day was very good. I had a very relaxing day, which is very rare. And of course, I knew I was going to be sitting here watching one of Professor Mallon's TEDx seminars. His TEDx seminars, which are always fascinating. So for me, an opportunity to learn from him any day, that's an exciting. I heard. How was it? It's cool. Yeah, that's right.
I'm from Blitar.
From Blitar.
Blitar. And I'm private teacher. Is your class,
My mother is from East End.
Oh,
Yes, I have been to Blitar.
okay.
Your English is very good, by the way. Did it get better after joining CS50?
Yes, I'm going to be the team of both of them. Okay, we only have 30 minutes of five-set chat, so let's get started. For the first question, this is for both Mas Menteri and Professor Malan. How will AI change education in the next 5 to 6 years? What are the most pressing problems that you think could be better and faster solved using AI? And how will a classroom look like by then?
Me first. So I think for us, and it's fitting that we're here today as such an international community, I think for students and teachers alike, who have been increasingly taking advantage of online courses or experiences, the support structure is about to get significantly better. And case in point is this doc, in that we don't have the resources, we don't have the humans to provide everyone in this room with a one-to-one teacher-student ratio. We're fortunate with the teachers in this room to be able to provide Zoom classes in collaboration with the ministry here. but there are tens of thousands, hundreds of thousands of other students and teachers around the world who have found their way to CS50, to so many other classes online, and they're largely on their own. And they might have online communities available to them, the Reddits, the Facebooks, and the Stack Exchanges of the world, but those are not necessarily expert communities, because so many of the people in them are themselves students, and even well-intentioned students might be very willing to try to help each other, but the answers aren't necessarily always accurate. That's just the nature of learning along together. And so I think with AI technologies, particularly virtually, we can finally provide the support structure that we're so fortunate to be able to in a residential place like Harvard or Yale or beyond, but have never for years been able to do at any sort of scale. And so for us within CS50, I think this is one of the most exciting applications.
Well, I think I completely agree with David on scaling the teaching assistant, essentially, function. I think for K through 12 education, I think it's a little bit more nuanced. I think that right now there is a massive amount of impact that can be done for teachers, not just students. I think everyone that thinks about AI for education always jumps straight to kind of a robot teacher, which is actually very, very true in many, many different scenarios, like David said. But I believe that there's a kind of another hidden benefit of actually empowering teachers to become a co-pilot to teachers. And how a teacher, like in this case, you have an AI co-pilot, a dumb co-pilot, that's helping you across the way. I do believe that teachers in Indonesia, especially, you know, they would love to be able to have someone that they can ask questions about the curriculum, that they would be able to ask questions about, okay, what's the best way I could actually get this point across, or teach this concept. What kind of a lesson plan would be fun and engaging to teach about astronomy, and so on. So I do believe that that kind of teaching assistant, but to make the human teacher better, is going to be also a very powerful use case for AI. So I think it will solve that problem. I think in the future, when the hallucinations kind of get minimized, I believe it's going to be a very, very powerful tool for students to actually get that one-on-one explanation about why they got something wrong. I feel like that's the most important thing, why they got something wrong, and explain and be able to answer questions like, why is this the case? That's something that simply a teacher teaching 30 students in a classroom cannot do. They cannot scale that into a minute. So for me, it's so important, the ability to be able to ask questions and get accurate results. I don't think it's there yet, but in the future, I think it will get to that level of accuracy and usage.
Thank you. So AI in education will enhance experience for both student and
That's right.
so what role teachers and professionals play in AI enhanced classroom, and what should be done to equip them with the right skill? What role teachers and professors play in the AI enhanced classroom, and what should be done to equip them with the right skill?
I do think, as Minister Nadine noted, I think there's an opportunity to enhance the availability of teaching in a classroom, even with the same human ratios that we have among students and teachers. I think very important is going to be to provide teachers, though, with the tools, with the software, that they themselves might not have the time or the technical expertise to implement, as we ourselves within computer science are able to do. Right now, I think we're in this strange time where business is booming in industry, and this is immediately a productivity booster for employees, the companies like Google, Microsoft, and the like. But honestly, so often does industry sort of dump on the rest of the world, particularly teachers, new technologies that now we have to figure out how to contend with. And this is why even we sort of just ban the software through policy outright until we can sort of figure things out. And I think that's, one, not an ideal model. I do wish some of our friends in the industry were more proactive with providing support for those teachers whose lives, whose classrooms are about to be disrupted, as they have this past year. But I think beyond that, providing teachers with the tools and the software by which they can create their own chatbots or their own automation tools for their classroom, so they don't have to just wait for someone to hand it to them, but they themselves can make them. I think that's the sort of support which they really provide.
Thank you. Okay, for the jobs. How do you see it differ from other universities?
The artists,
Policy does offer
policy that Harvard.
the field with the source
Sure.
of AI used to the man.
Sure. So Harvard is a very big place, and I think to its credit, some months ago when ChatGPT really made this big splash in the world, they provided faculty members like myself with possible policies that we could adopt in our classroom, possible language we could put into our syllabi and documents that explain the course's structure to students. But they didn't tell us that we could or could not use AI, nor did they tell us how we should or should not use AI. Some of this, I think, is just from a place of a research institution sort of doing the right thing academically and allowing many people different to explore. I think practically speaking, many of the folks just didn't know what was possible or what to do, and so all the better to defer perhaps to local experts. That said, I do think that summarily just banning tools like this for the long term is clearly the wrong solution. As I alluded to earlier, even if a school might disallow students through firewalls from using ChatGPT, I mean, they can just pull out their phone or VPN. I mean, every student out there knows far more solutions than we to solve those problems. And so that's why I think they should really consider, as places like Harvard have encouraged and allowed, faculty to find more positive uses for it.
How do you see it differ from other universities?
How do I see it differing from other universities? I think exactly in that way. I think Harvard and certain institutions have taken a very open-minded wait-and-see approach, which I do think is the right approach, letting thousand flowers bloom, so to speak, and figure out what are the right and the wrong ways to use it. And we, CSFP, are just one example thereof, either way. But I do think that universities that have clamped down is probably the wrong thing to do.
Thank you. This is very clear explanation. Okay, for how do your evidence-based learning transform into policies visible through current technological advancement and the lens of the benefit of AI, while at the same time answering the need to maintain human agency in the learning process?
I do think that AI is only as helpful as the humans that are using it. So if we do not have a digitally literate, and digitally literate does not mean taking CS50. It's rated way too high. Digitally illiterate is being able to use apps and computers and in general, know how to work applications, right? Not create them. Some of you can do that. So, digital literacy is a fundamental policy in Madagascar. You'll know how important it is because all of our group graph, we don't teach them any pedagogy. There's no pedagogy. We're not teaching them how to become better teachers. Okay? We're teaching them how to become better leaders. The one competency that we prioritize in their training is digital literacy. We teach them how to use different things, how to spread their ability to, use Zoom, how to set up meetings, how to use apps to show how to use presentations as a form of leadership. So, literally, I think one of the most important skill sets that we need teachers to know is how to use basic technology, and then make sure their mindsets are correct so that they'll learn on their own. Right? So I think that is something that we always prioritize in all of our policies. We also gave, first time in history, the most number of laptops to schools, especially in the regions that don't have access. We gave laptops, routers, millions to schools everywhere across Indonesia, and also we provided free-to-use applications. I think we're the first ministry in Indonesia to have a really dedicated technology team that's huge. They use technology team that produces free-to-use apps to support teachers and principals. And so that digital transformation is a pivotal part of scaling anything that we do. So emancipated learning will not be able to scale without technology. We did not have an option. It wasn't because we'd like to be the leaders. We had no choice. There was no choice. 3 million teachers. How are you going to do that? How are you going to upskill 3 million teachers without having IMM? Right? It's simply impossible. So it was more out of necessity. I wanted to kind of comment also about where this is headed in terms of that, to the point that Professor Mal was saying about cheating. I completely agree. I do not think banning this product is going to be helpful. I think people are just scared Because deep down, I think in every educator's heart, there is a question that makes them very, very uncomfortable. If solving problem sets and writing essays is no longer going to be something that is proof of competency, what is? You cannot stop this tool. You have to, at some point, you're going to have to give up. Every teacher and university is going to have to give up. You will lose this battle. This tool will be everywhere. That is 100% certain. So given that, what happens to your grade? What happens to what happens how you evaluate the student's ability to understand what you are trying to teach them? All of that has to change, and that's really uncomfortable. And we're not talking just schools in Indonesia. I'm talking about the top global international high schools and universities are struggling with this question because that is how they have assessed students for the time. But for me personally, not coming from the education space, I kind of love it. I love this confusion phase because it means that finally this whole debate about the relevancy of what school experience should be to the real world, where no one is asking you to write an essay and evaluate it based on how good your grammar is, where no one is asking you to actually solve very specific discrete mathematical problems all the time. None of that is actually what ultimately is going to be most useful. So, what I love about generative AI is now it's forcing everyone, oh, actually, the only way around this is we've got to go and get kids together and do stuff. We have to create things. We have to execute projects. We have to actually complete teamwork activities and do it. And never before has that debate been so lively because of Gen AI. So I love the confusion. I think it finally opened people's minds because they're forced to think of other ways of actually proving retained ability outside of just exams and essays, even essays. So that's my view as an outsider who has now become someone who begins education. I kind of love it. Sorry.
Chromebook.
And then I can use it for the scratch or everything to my class. Okay, and then the next question for Professor David. What message will you give to educators who will have to deal with AI in their classroom and to students who are about to navigate the use of AI in their learning journey?
I would echo these remarks about just not fearing it and trying to view it as an opportunity. I would try to not think about it even grandly, but just on a very small scale. Like, what are some problems that software, even off-the-shelf software nowadays, can help you with? For instance, I taught high school for 1 year before returning to university years ago, and honestly, I had 115 students total across 5 classes, but that was enough students. We met 5 days a week where I could not grade their homework, for instance. So what I would do is what any good sort of statistician would do, I sort of randomly sampled. So maybe on Tuesday I would grade this class, maybe on Thursday I would grade this class. But meanwhile, they're having 4 classes where they're not getting feedback on the homework, which is not ideal, but was sort of necessary because I only had so many hours in the day, and I also had to prepare for the next day. And so my mind immediately goes to using software, AI or otherwise, to help with tools like that. And I think the catch there too is that so much of educational software just tends not to thrive. It tends to be a difficult market for companies in the US and locally to get into because the resources aren't necessarily there. And so I think too, seeking out freely available resources from industry, from other universities, from other schools, I think is the key to finding tools like that because they are out there. But again, a lot of it is about accessibility and education and relevant teachers themselves.
Certainly not
They
when
just
you
found their own way
can
with
figure this out intuitively much better than you can or me. But the adults like us, so I come from the technology background, and when I talk to a 16 or 17-year-old, it is very obvious that they are way ahead in terms of digital literacy and understanding what productivity tools you can use to achieve it. The gap is so big. Even 10 years, I'm about 40 years old now, 10 years the gap is really big. 20 years it's enormous. 30 years I have no idea, that they're just amazing, they're alien to me. So my message is to the adults and teachers. This will be very weird and very strange and intimidating in many, many ways because you are unfamiliar with life. People in this room probably are far less intimidated. You've shown your curiosity to want to learn about it, and therefore you'll be less disconnected to your students. And even better, you can actually help guide your students to enter not just being a consumer of these tools, but actually someday a producer or creator of these digital platforms, which is wonderful, right, to do that. But my advice would be, one, if you're scared about it, that's okay, that's a normal feeling. A lot of people, but you don't have to be that scared. You don't have to be that worried. Because ultimately, you will find a way to make it work for you instead of making your enemy that you're constantly fighting against. And I think that's the mindset that is required, to know that this is going to be your friend. Okay, if you start with that, then you can create guardrails for that friend to constantly be working for you instead of against you. But if you're coming in with the mindset, this is my enemy, it's never going to work. Right? So I think that mindset coming in is going to be very, very important. And never feel embarrassed about asking your students how things work. That's going to in many ways they're going to be better at. Let them play with it. And they will figure it out much faster than an adult does. And then ask them and have them. I think that part is really discussed in how much the next generation can really help. I think those would be the things that I would recommend.
Professor David, how can AI facilitate cross-disciplinary collaboration in education, and what challenges that this pose for traditional education and craft?
That's a really good question, and I haven't given it much thought, but what immediately comes to mind, honestly, is a problem I've had for years, which is within CS50, many of the homework assignments or problem sets, as many of you know, we try to draw inspiration from the real world. We have a problem set on digital forensics, a problem set on cryptography or encryption. In the past years, we've had problem sets on music. We have one on DNA now. The problem, though, is if I am the source of these problem sets, we can only intersect with other fields with which I am myself familiar, because otherwise I don't know how to find those intersections. Now, thankfully, I have smart colleagues. So the DNA homework assignment, with which so many of you are familiar, that came from someone else. Ryan, you helped understand it, because he did biology far more recently than I did. It was in 9th grade back in a long time ago. But where my mind immediately goes is that I already am having conversations literally with ChatGPT most every day to ask questions of its better learners and software computing. But it's not a big leap for me to say, what is a homework assignment I can give my students that involves both computer science and biology and chemistry and physics and arts? And honestly, in the absence of my knowing a smart human or colleague who can answer that question for me, I bet already ChatGPT, if I try this tonight, will give me some really good ideas. And that's not to say I will know the other side of the fence, the material, but I can then ask it follow-up questions. Tell me what your computer scientist needs to know about this topic or that. And I can't emphasize enough how exciting I do think this is, to Minister Nadeem's point, of the co-pilot beside you. And you have access now as teachers to a subject matter expert that's pretty good now and is only going to get better tomorrow and onward, that you can ask any and all questions of. And even within my professional life, there are friends that I can ask questions of, colleagues, and I can send them an email, I can catch them at lunch, I can send them text messages, but I have to mentally keep track of who I've annoyed the most recently with my questions so I can go ask someone else. But the duck, the AI, does not care. As our own student said, no question is too dumb. And this is amazing to have virtually sitting next to all of us as teachers. very exciting despite all of the concerns that might be otherwise out there.
Problem setting CSFP, you provide the two kind of problem setting.
More and less.
And less problem setting. Very related or because in different yes.
And less comfortable.
Question. Will AI enhance creativity and problem solving for students if so?
Absolutely. That part is easy. It's an easy question to answer. Will it enhance creative problem solving? Yes. It depends. Okay, let me say it absolutely has the potential to do that because it is able. Right now, you can prompt an AI to inspire you. You can prompt ChatGPT to inspire you on stories. Even it's got a rudimentary level of imagination built into it because it uses human language to learn. Right? So it's read every book. It's read so many stories, way more than you have. So in that sense, it's very powerful. Now, if certain people use it simply as a substitute, okay, if all school is a series of homeworks and assignments and people are just using ChatGPT to do the work because they're not interested in learning, students are using it to cheat essentially, then yes, it could potentially become a blocker or a negative one for creativity. But then again, that actually challenges teachers to think beyond about how to bring creativity back into class, how to bring team-based creativity into the class, and not just simply looking at individual work as the most important piece of a student's experience. But I think that having, like what David said, having every single expert on your doorstep. So it's the great equalizer. It's the great level. You don't have to have had, for example, the best networks. You don't have to have had the most amount of money so your parents could tutor you in that area. You don't have to. Through this platform, all the information is available there. Now, what you get to do with that information is up to you. And I think that's what makes it so powerful as an equalizer. To be able to launch a new business based on getting mentoring from AI chatbots, right? Imagine having a VC chatbot teaching you how to structure a deal so you don't get, cheated on by your investment, or launching the first MVP of a project and being able to see, getting feedback from that expert AI about what could be the pitfalls of that minimum viable product that you want to release, whether it's a new good, or you want to sell it online, or it's a new type of agricultural product you're growing in your village. It's so amazing the amount of information you can get. And I think to teachers and educators, then understanding, okay, why did the assessment not show? Why did we not have any more subject-based assessment? Why did we stop testing your students? What information they know. Instead, we tested what could they do with it. So that kind of brings this whole point full circle. What is the point now? This new digital transformation. What is the point of education? Is it about cramming as much information and knowledge into our kids? No. It is to be able to equip our kids to love learning for the rest of their life and to know what to do when they get information. As long as you believe that, you're going to love ChatGPT. Right? If you don't believe that, you're going to hate ChatGPT. Okay? So, I think that's kind of the difference in impact, positive and negative, to this video.
Okay, thank you. Last, for the last one sentence for the educators for management of CS50X.
Last thing I'll say. I can only say that our hosts. This was CS50.
Finally, now we have reached the end of this fireside chat. I would like to say thank you to Mr. David and Mr. and all the participants tonight. Thank you for your attention and have a great day. Okay, thank you.
Flown all the way from Lintan just to be here. She's a participant from last year. So this is a great opportunity for a photo group. Of course, the three of you. Let's take a picture first, the three of you. Mas Menteri, Professor David, and the moderator. Take a picture, just the three of you, before our moderator steps down. Setelah foto bersama ini nanti Miss Imah kami persilahkan untuk turun dari panggung dan kembali ke tempat duduk. So we'll have a photo group first, and afterwards we kindly request for Mas Menteri as well as Professor Malin to please remain on stage for the gift presentation. All right, thank you, Mrs. Ah. You may step down and return to your seat. Once again, ladies and gentlemen, let's give a round of applause for our moderator.
Gimana?
Okay, Mrs. Ah, thank you so much. And now, Mas Menteri will present a gift as a memento to Professor Miller. And to join them on stage, we kindly invite to come up on stage Ibu Nunung, Mas Day, and also representative from GIS, Mr. Phil Rickard, as well as Ibu Maya. Miss Maya Nelson, ladies and gentlemen. We will have a photo group first. Yes. After the photo opportunity, we kindly request for Ibu Nunung to present a gift to representative of Jakarta International School, to Mr. Phil Rickard. Thank you all. Mas Day, Ibu Nunung, Mas Menteri, Ibu Maya, Professor Malin, as well as Mr. Phil Rickard. Thank you so much. Please return to your seat. Okay, before we end our event this afternoon, we have one more agenda left, ladies and gentlemen. So please remain on your seats. Please stay on your seats because we are going to have a group photo. So I'm going to invite the photographers from the stage, and we are going to take a picture of all of you who are attending today's event. So please remain, please stay on your seats. Okay, I'm going to get it away. Give a generous smile. Okay, 1, 2, 3.
Yang foto masalah, mana gitu sih?
One thing for sure, ladies and gentlemen, from this event and also from the fireside chat, we hope that it was very, very insightful. And one thing for sure, that this course can enhance the competency of our Indonesian teachers, open their minds, and be more connected with the students, because they are the generation of our artificial intelligence. And of course, they can transform the minds as well as the characters of young Indonesians. So this ends our event for today. Once again,